Hey, Mr. Son here today. We're going to be talking about exponents, and we're going to be looking at the laws of these exponents as well as multiplication of polynomials and kind of putting both of those concepts together to kind of tackle a couple kind of rough problems for the most part. But for the most part, as long as you stick to the rules of exponents or the law of exponents, these problems aren't as bad as you might think, okay? With a little bit of practice, you'll be knocking these out in no time. All right, so let's start with just a quick review on the law of exponents, okay? So for the most part, when you have two exponent problems multiplied together, so you got x squared times x to the fifth, when the base is the same, you can go ahead and add exponents when we multiply these together. So the answer to this should be x to the 7. Again, you should be reviewing this. I have a website that has a review of all these laws of exponents. You should check that out before even watching the rest of this video, okay? X to the 7th, x squared, we have the same base. When we divide these terms, we subtract the exponents, okay? So the answer to this should be just a straight x to the 5th. When you have negative exponents, you are flipping the term and, for the most part, the base and the exponent to the opposite side of the fraction bar. So if there's no fraction bar, you could imagine that this x to the negative 2 is just over 1. And to get it to be a positive exponent, which is like pretty much what we want, you just flip it to the other side of the fraction bar and that will make it positive. So this is indeed 1 over x squared. So you see x to the negative 2, it's really just 1 over x squared. Now 1 over x to the negative 3, again, to make it a positive exponent, you would flip it to the other side of the fraction bar. So this is just equivalent to x to the 3rd power, okay? Meaning that if I plug a 2 in here, if you type on your calculator 1 over x to the negative 3 and you plug a 2 in there and you plug a 2 into 2 to the 3rd, you'll get the same answer, okay? Then lastly, there's the rule where you go ahead and you have the parentheses and you have an exponent on the outside. I like to think of this kind of like the distributive property. So this exponent, this 2 on the outside, will get distributed to each of these exponents, okay, or each of these terms, okay. So the 2 squared the 2 itself will get the squared, the a will get it, and what we do here is we multiply this. So 2 times 2, that will give me a to the 4th, and then b, if there's nothing there, you just have a 1 up there. You'll multiply the 2 times the 1 to figure out that we have just a 2 there, okay. To finish this up, 2 squared, that's just equals to 4. We got a to the 4th, we got b squared, okay. If you have any questions about that, call me on over. I can clarify that a little bit, all right. Next, let's go ahead and look at a little bit more complicated problem. So now we're going to start multiplying these polynomials together, okay? So for this first one, when you multiply these two terms together, make sure you start by multiplying just the leading coefficients together first. So the 2 times the negative 5. So that's going to give us, oopsies, negative 10. Then what you do is you start multiplying the letters together that are the same. For example, the p times the p, okay? And because they're both p's, you're going to go ahead and add the exponents, okay? Because of that multiplication principle that we have for the laws of exponents. So p to the 3rd times p squared is just going to be p to the 5th, because 3 plus 2 is 5, all right? So that is the answer for that multiplication problem, okay? Upping the ante a little bit, let's see if we have like this divided problem going on or this division problem and we have to simplify it. First of all, we are not allowed to use exponents with negatives, so we have to make them positive. So the first step would be to make all of these exponents positive. To do that, the only one that's negative is q to the negative 3. We have to flip it to the other side of the fraction bar. So now what we're looking at is p, or 3p, oopsies. Let me erase that before you guys get extra lives. Squared, okay. And then on the bottom here, we're going to have 2p and then q cubed, because that, again, is how we make the exponents positive, by flipping it to whatever opposite side of the fraction bar it is. If it's on the top, you go to the bottom. If it's on the bottom, you flip it to the top, and that makes the exponent positive. Now, we can simplify by, for the most part, canceling out some of these variables that are on top and bottom. Now, you'll notice that there's 2 p's on the top. There's p squared. It's just p times p. And then a p on the bottom, okay? For the most part, we can cancel out one of the p's because there's 1 p on the bottom, 2 on the top. So pretty much what that means is when we cancel out one of the sets of p's, we're just going to have a p left on the top and no p's on the bottom, okay, and that's how you could go ahead and simplify that, okay? So we have 2q cubed on the bottom, and that would be pretty much done, simplified, all right? Let's look at another problem real quick. The next problem we got is a little bit more tricky, okay? So first of all, let's go ahead and get all these exponents to be positive numbers, okay? To do that, I'm going to take all of these and flip them to the other side if it has a negative number, okay? So this needs to be flipped over, and this a to the negative 3 needs to be flipped over, okay? Before I begin, I'm actually going to make a fraction out of this, so it's a little bit easier for me to keep track of these movements. So first of all, you have to understand that when you have a multiplication with two fractions, you are just pretty much combining all these things together. You're sticking them together because that's what multiplication is all about. So I've seen people do this before where they just kind of stick everything together at the beginning, so it's a little less confusing. So they just kind of stick everything together, okay? Because again, everything's being multiplied straight across the top and everything's being multiplied straight across the bottom, okay? And then what I've seen people do before that tends to work for them is take all of the exponents that are negative and switch them to the other side. So that's what I'm going to do next. So I got 4a squared, 3b squared. Those are everything that, for the most part, with positive exponents on the top. These guys right here, this b to the negative 3 and a to the negative 3, the reason I didn't write that is because I'm going to put those on the bottom, okay, because those will become positive exponents when written on the bottom. So they're going to join the a squared and the b down there at the bottom. Okay, so we got b cubed now, and then we got a cubed now here at the bottom. Okay, now we can simplify by multiplying things together. Okay, so this 4 and this 3 can be multiplied together, and that's going to give me 12. The a and b can't be combined together, so I'm just going to put them next to each other because, again, they're not the same. So you can't multiply them together and use that exponent rule that we were talking about earlier. On the bottom, we can do some multiplying together. So this a squared can multiply with a third, or a to the third, which becomes a to the fifth when we add those exponents. B times b cubed will become b to the fourth when we add those exponents. And now it's just time to simplify it, do some canceling, okay? The number itself, 12 on the top, has nothing to cancel with on the bottom, so we're just going to leave that at 12 on the top. However, you'll notice that there's more a's on the bottom than a's on the top. In fact, there are 3 more a's on the bottom than there are on the top. So we can cancel away 2 of those a's, and we're left with 3 a's here on the bottom. Same with the b's. There's more b's on the bottom than there's b's on the top. So the answer, the final answer, will have the b's on the bottom, not on the top. So there's 2 b's on top, 4 b's on the bottom. We can cancel away 2 of those b's, which means we have 2 left over on the bottom. So we got b squared left here. Okay. So the final answer is 12 over a cubed times b squared. Okay. Let's try one more problem. Last problem that I want to try is this one. It's kind of a nasty one. All right. Now, when we start having these exponents, everything raised to an exponent with parentheses and stuff, what I like to do before I even start doing what we did last time is distribute those in first before we start moving the negative exponents, okay? It's kind of like order of operations. You kind of want to do these outside of exponents first. That's just kind of how I do it, all right? So first of all, I'm going to distribute this 2 into all of them to make sure that this kind of everybody gets a squared to it. So 5 is going to be squared. We're going to have x squared. Now when this 2 gets attached to it, it's going to be multiplying this 2 up top, so it's just going to be x to the 4th. This y, it's what to the first power. The exponent itself, 1 times 2, will give you y squared. Okay, and then again, I'm going to put that over 1, kind of like I did earlier. Okay, now I'm going to distribute this negative 2 now. So this 2 is going to be raised to the negative 2 power when I distribute it to that. This 2 right here, 2 times negative 2 will give me the exponent of negative 4. So x will be raised to the negative 4th power. This negative 2 will be distributed here. Negative 1 times negative 2 is just going to be a positive 2. So it's just going to be y squared. Now let's go ahead and distribute this to the bottom. Okay, so this negative 2 will also go down and multiply every exponent on the bottom as well. So we got x to the negative 3. Negative 3 times negative 2 is going to give me a positive 6. So it's going to be x to the 6th. And then y to the 2nd, 2 times that negative 2, again, is going to give me y to the negative 4. Okay. Now we're back in the same position we were before. We can go ahead and smash those things together, and then flip or put all the ones with negative exponents on the bottom or on the top, depending on where the negative exponent is. Okay, so what I'm going to do is I'm going to multiply things together real quick. 5 squared, I'm just going to rewrite that as 25. I'm going to stick everything together like I did last time. So I have x to the 4th, I have y squared, I have a 2 to the negative 2, which needs to be flipped over. I'm not going to do that just yet. I have x to the negative 4, and I have y squared, okay? Now on the bottom this time, I only have, for the most part, x to the 6th power and y to the negative 4. Now we got to do our flips, so anywhere you see a negative exponent, it needs to be transferred. So I'm just going to go ahead and do that, all right? So I have 25, x to the 4th, y squared, and then another y squared, okay? Also, I'm going to write another y to the 4th because this number here has a negative exponent, so this needs to be moved up top. So I'm going to have y to the 4th here, okay? Now, going to the bottom, we have this 2 to the negative 2 power that's going to just change into a whopping 2 squared on the bottom here. We have an x to the negative 4 power, which becomes x to the 4th power down here. And again, we already had an x to the 6th, so there's what we have on the bottom. Now it's time to go ahead and do some multiplying and simplifying. So we got x to the 4th. It has nothing to multiply, but we do have a couple y's here. So y squared times y to the 4th. With that multiplication problem, we're just adding all those exponents. So pretty much we have a 2, and a 4. So adding 2 plus 2 plus 4 gives us y to the 8th up top. So we have 25, x to the 4th, and then, whoopsies, y to the 8 up top. Now on the bottom, let's just do this real quick. 2 squared is just going to give us 4. X to the 4th times x to the 6th. Again, they have the same base, so we can add those exponents. We get x to the 10 when we do that. And for the most part, now we can go ahead and cancel if we have commonality between the top and the bottom. Okay, so there's 4 x's up top, 10 on the bottom, so they're going to end up being on the bottom. We can cancel away 4, which means we only have 6 left on the bottom here. So the final answer should be 25 y to the 8th over 4 x to the 6th, because again 4 of those x's canceled, okay, from the previous step, and that is our final solution. Hey, this is a pretty tough concept, so if you need any help at all, call me on over. I can walk you through a couple more examples. All right, have a wonderful day. Toodles. Bye.